Today, on how it's made. Three-wheeled vehicles. What you get when you cross a race car and a tricycle. Baseball bats. We'll cover all the bases to bring you this story. Artificial bonsais. How to fake a centuries-old botanical art. And trombones. We'll tell you all about the brass tactics. Three-wheeled vehicles were introduced in the 1990s as exotic concept vehicles. This one is like a motorcycle on steroids. It has what's called a reverse trike design, 2 wheels in front and 1 in the back. It hugs the road like a race car, yet is legal to drive through city streets. This vehicle goes from 0 to 100 kilometers per hour in just 4.1 seconds. No faster than a motorcycle, but it definitely turns heads. Production begins with 34 steel tube components that will form the vehicle's chassis. A worker places them in an assembly jig. This positions the tubes for welding. After clamping the components in place, it takes the worker about 4 hours to weld 68 different areas together. For efficiency, 13 of the larger, more complex structures are pre-assembled. The steel tubes measure 3.8 centimeters in diameter, but the metal itself is only 1.5 millimeters thick. They're like those used in the aviation industry, strong yet lightweight. This company uses a visual reference method to assemble smaller parts of the vehicle. Before starting, a worker places 80 components on a board with labels that identify them. This way, he's certain he won't forget any nuts, bolts, bearings, brackets, or horns. Using an electric crane, a worker hoists the vehicle's 4-cylinder, 152 horsepower, 1200 cc motorcycle engine into the chassis, now tinted black. Using a pneumatic wrench, he attaches it with 6 bolts and 6 nuts. Here, a worker assembles the 50 parts that make up what's called the footbox. This includes aluminum clutch, brake, and gas pedals. The brake pedal is thicker to withstand more aggressive use. The vehicle decelerates from 100 kilometers an hour to 0 in just less than 29 meters. He coats part of the brake pedal with a liquid sealant so vibrations won't loosen it. Another worker then mounts 2 output hoses and 2 plastic reservoirs for brake fluid. The brake fluid must withstand heat of 343 degrees Celsius, 30 degrees hotter than what's required for most cars. This enables better engine performance. He installs the footbox onto the front of the chassis using 3 bolts. Controlling the speed with the footbox is crucial, since top speed for the vehicle is 230 kilometers an hour. Next, he installs part of the suspension system, a cylindrical gas shock absorber. This attaches to the brake system, which is a zinc-plated rotor and an aluminum caliper. Then they attach what's called the 4-into-1 exhaust manifold. The 4 pipes merge into one to vent the exhaust fumes from the engine. They install the electric fan and radiator assembly. Next, a worker attaches a removable leather-covered aluminum driving wheel to the steering column. The driving wheel locks into place with a spring-loaded latch system. Just like a race car, you attach the steering wheel after you sit in the driver's seat so that you can get inside the vehicle. The collapsible steering column is part of the instrument cluster. This includes dials showing the vehicle's speed, mileage, and fuel. There are also switches for turning signals, hazard flashers, high and low beam lights, and to start and kill the engine. Next, workers install the rear wheel to another part of the suspension, called a swing arm. They attach it with 1 bolt that's nearly half a meter long and 2 smaller bolts. Workers then install a chain on the rear wheel assembly. When the vehicle's running, the chain's 94 links revolve on 2 sprockets to make the wheel turn. Rubber O-rings on each link prevent dust from damaging the chain. Finally, workers attach 19 molded fiberglass body parts. This factory offers 6 standard colors and several custom colors. When assembled, the vehicle is nearly 3.5 meters long, almost 2 meters wide, and just over a meter high. If you have a motorcycle license and a spare $50,000, you too can burn the pavement on this mean set of wheels. If you think a baseball bat is a pretty simple thing, well, you're out in left field. Making a bat means balancing things like weight and thickness. The material it's made of can make a difference. Metal bats hit the ball faster. However, the pros use wood bats because of league regulations, and even the type of wood might impact the score. Barry Bonds cracked a home run record in 2001 with a wood bat like this, one made of maple, instead of the usual white ash. They can never tell just by looking at it that a chunk of maple has what it takes to make a good bat. So they weigh it to make sure the wood is really as thick and heavy as it appears. Next, pointed prongs grip the wood and spin it, while a carbide cutter rounds it. This is a very modern lathe called an XY machine. The rounded blank goes into a room called the library, joining others on the shelf that are waiting for their chance at the big leagues. A worker selects one of the blanks to fill an order that specifies a certain model and size. He weighs it again to make sure it measures up to what the player has ordered. The blank goes onto the XY machine and spins. A computer guides the cutter as it moves on rails and carves into the blank. It whittles 2.5 centimeters of wood from the blank in order to form a handle. It takes a total of 3 passes on this cutter to make the rough shape of a baseball bat, but it's quick work, completed in just 3 minutes. Now it's time for another weighing in. The bat is substantially lighter, which is what they want. Next, he measures the end of a completed bat with a caliper. Using a square-edged scraper, he rounds the knob as the bat spins on a more traditional lathe. He measures as he cuts. With another caliper, he checks the thickness of a completed bat and compares it to the one he's just carved. Now he takes a turning tool called a skew chisel. With its pointed tip, he cuts into the bat's handle, just above the knob, to narrow the shoulder. Again, he measures as he cuts to make sure the diameter is just right. Using the skew chisel, he shapes the slope of the bat, repeatedly checking with the caliper to make sure it meets specifications. He slims down the handle a little more. Then he angles the top of the knob with the chisel. He shapes the rest of it with a square-end chisel. Next, he curves the bat's barrel using the same tool. This gets rid of sharp edges that would cause a ball's impact to ripple down and jar the player. Then he goes back to the knob and completes the shaping with the skew-end chisel. Because the tool is extremely sharp, he can carve very precisely. The bat is now within 14 grams of its final weight. Using an electric sander, he smooths down some of the rough edges. He switches to a finer grit to finish off the job. As he sands, he measures, because this isn't just about getting the surface smooth. The bat has to be exactly the right size and weight for the player it's being made for. Now he places the bat's knob in an end mill. A spinning carbide disc cuts around the holes made by the pointed grippers on the lathes, producing a gentle scoop. Next, a bigger disc carves into the barrel, cupping it. Some players prefer a cupped bat because it balances differently. Now he places the bat on the scale for the final weighing, and it's exactly what the player ordered. He brushes paint onto the barrel and rubs stain into the lower half of the bat. He presses decals onto the bat so it sports both the brand name and distributor. Then he stamps the model number in gold ink and tops everything off with a light coat of varnish. Now this maple bat is ready for the big leagues and some heavy hitting. Bonsai is a Japanese word that means plant in a pot. Growing trees in pots is a revered art that actually began in China more than 2,000 years ago. During the past century, creating artificial trees known as bonsai zoke has evolved into a hobby with global appeal. Whether it's rustic pine, flowering cherry, or Chinese elm, bonsai zoke can be made to resemble a variety of trees. Some include stones and small statues, a Chinese tradition known as penjing. A craftsman starts by wrapping 13 strands of wire with stretchy, sticky tape used by florists. He uses 13, partly out of respect for a traditional Asian preference for odd numbers. Later, these wires will form parts of the trunk and branches. He wraps the wires with strips of paper towel for thickness and flexibility. To hold the paper towel in place, he wraps the ends of the wires with more floral tape. He then separates clumps of plastic pine needles from their branches. Ironically, this fake vegetation is imported from China. Next, he snips off the ends of the branches, creating segments about 2.5 centimeters long. To reinforce and support these segments, he wraps them with tiny wire that's 0.5 millimeter in diameter. Next, he wraps the segments with floral tape to give them a more natural, branch-like appearance. Then he inserts these segments into the pine needle clumps. The thicker end becomes the bud and holds the clump on the segment. The craftsman now places 3 of these leafy segments together and attaches them with wire. He bends them sideways in the same direction. This mimics the tendency of natural branches to lean towards the sun. For more mature-looking buds, he uses different 3-headed artificial segments. For integrity, 2 different types of buds are never used on the same tree. To add character, the craftsman uses a piece of weathered driftwood as the base of the trunk. He anchors the long wrapped wires into styrofoam around the bottom of the base. He staples the wires to the driftwood and wraps floral tape around the wires surrounding the base. Then he twists the wire to form a sinuous shape, what the Japanese call moyogi. He covers the trunk with soft gray modeling clay, adhering closely to the shape of the driftwood underneath. This will later be covered by artificial bark and moss. This process can take several hours, just part of the 4 to 6 days it takes one worker to make a bonsai zoke. The craftsman then applies slow-drying glue to one side of strips of rice paper. The strips are 5 centimeters long and 2.5 centimeters wide. He uses about 50 to cover the trunk, like bark on a tree. He dabs them with a wet rag so that the creases will remain when the glue dries. The creases make the bark look realistically aged, one of the hallmarks of a good bonsai zoke. Craftsmen are careful to place the branches in the traditional triangle shape. The lower branches must droop, as if weighed down by the elements. They add the leafy segments to the ends of the wire branches, attaching them with wire and floral tape. Using a knife, the craftsman trims away the excess styrofoam around the tree trunk. He then places the tree into an argyle pot that's 22 centimeters in diameter and 5 centimeters high. Using a sculpting tool, he covers the styrofoam in the pot with brown modeling clay. Using slow-drying glue, he covers the clay in several shades of fake moss. They range in color from dark brown to light green. He doesn't let the glue dry between each layer because the blending of moss and glue ensures a more natural-looking ground cover. He gently blows on the moss to scatter it across the base. He also applies glue further up the trunk, adhering moss that's thicker and lighter in color to resemble lichen. The finished bonsai bouquet is 45 centimeters high. It needs none of the constant care required by its natural twin. Depending on their size and complexity, artificial bonsais range in price from $50 to $800. The adage, "It's hard to improve on a good thing," certainly applies to the trombone. The modern trombone isn't really much different from its medieval predecessor, known as the sackbut, with its distinctive S-shape, hand slide, and bell section. It's a blast from the past, and a pretty loud one, but it can also sound smooth and mellow. The trombone literally slides down to the low notes. It's the only instrument with a hand slide to lengthen it in order to change pitch. To make a trombone, they cut sheet brass in the pattern of a bell stem. They shape it by wrapping it around a steel rod. Using a nylon-headed mallet, the worker hammers the brass to shape it further. It takes just a few minutes for him to hammer out a rough bell stem form. He spreads open the stems slightly so he can make small notches on one edge with snippers. Then, with a brass-headed hammer, he taps down the notches so they hold the edges together. With an acetylene torch, he joins the notched seam, melting in a brass alloy wire to bond it securely. But the seam overlaps, and it's too thick, so he runs it through a seam roller. 2 tons of pressure thins it. But now, the bell stem is too flat. To round it out, he shoves it onto a bell-shaped rod and hammers it back into shape. Then he irons out the hammer marks with rollers. The bell stem, fitting loosely on a steel mandrel, goes through a draw bench. A hydraulic cylinder pushes it through a thick lead washer, pressing it tightly around the mandrel to its shape. To make the bell flare to attach to the stem, he puts a brass disc on a spinning lathe. Using pliers, he turns the edges of the disc to prevent it from flapping while spinning. With a lever, he manipulates a scissors spinning tool, pressing it against the turning brass disc. This shapes the disc into a flare. Making a trombone flare is a delicate business and is the work of a skilled craftsman. Getting it right is critical because the shape will affect the tone of the trombone. Next, with a torch, he braises the flare to the bell stem. The bell stem and flare now turn on a mandrel, while he presses against the seam with a wooden tool. This flattens the seam and gives the bell its final shape. Now it's time to make the tubing. A hydraulic cylinder pulls it on a mandrel through a die, stretching it considerably. In this way, both the diameter and thickness of the tubing are precisely controlled. Then, they become ice tubes, after they're filled with water and put in the freezer. The ice will keep the thin tubing from buckling in the next process. With a lever, he bends the tube around a U-shaped block. As he works it into a U-shape, the tubing hardens. After the ice melts, he places the U-bend in a balling-out die. He lubricates the tubing with oil and places a steel ball at the top of the tube and presses it down. He drops in smaller balls, and they push the first larger ball through the U-tube. This stretches the inside of the tube, rounding it to the correct diameter, and then the balls exit at the other end. Now he pieces the tubes together and solders them the same way a plumber joins copper tubing. He adds a loop for the valve section. In total, a bass trombone has 2 3/4 meters of tubing. Straightened, that's enough to reach from the floor to the ceiling. But of course, trombone makers are more interested in musical highs and lows. Finally, he solders a brace into place to add structural strength to one of the loops. A diamond-tipped tool engraves the company logo onto the trombone's bell stem, and a cloth buffing wheel spins against the trombone flare to polish it. This custom trombone has been built in approximately 50 hours, something worth blowing a horn about. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howithismade.net.